Welcome to GearVR Framework Tutorial Lesson 5. In this lesson, we're going to learn about sound and text. Sound effects are done with the Android layer, and there are three primary components that you would use there. The sound pool is used for sound effects. These are short things that come and go quickly. The media player is used for music. That would be for playing a longer sound that is more continuous. And then Cardboard Audio Engine is used for 3D spatial sound, and that sound actually sounds closer. It's louder when you're closer to an object in the scene, and it's further away that the sound is a little bit softer. Now, in our example, we're going to make a balloon popping sound. So what we're going to do is we're going to play the balloon pop sound when the user touches the pad while the cursor's in one of the balloons. So that's going to be considered scoring a point. And we're going to implement this as a sound component. So what we'll do is we'll preload the balloon pop sound at the beginning on init, and then the sound will be played when we have a touch event. So the sound effect component, like our others, it starts by extending GVR behavior, and in the constructor, we're going to tell it what the Android sound pool that we're using is, and then we're going to give it the path of the sound file, and in this case, we're going to assume the sound is in your assets directory. There's more complex logic if you want to get it from a URL or if you want to get it from the SD card, but we're going to assume that it's one of your assets. And so here, we're going to make an asset file descriptor by getting the context that is always inside the GVR context. This is your Android context. And then this will give you your assets directory, and then this will open the sound file that's relative to the beginning of the assets directory. And then the sound ID is how you identify this particular asset to the sound pool. To play the sound, you have to call the player with play, and you have to give it all of the things you want to use, the left volume, the right volume, whether you're looping or not. And so what we do is we keep these as variables to the sound component and provide access so that if you're a programmer that wants to change these things programmatically, maybe you want to play the sound effects louder for balloons, certain balloons than others, you can do that. Let's add the sound component to Android Studio. We do that just like we do the other components. We make a new Java class, and then we copy the stuff from our presentation into the Java class. So we're going to call this class Sound Effect, and we're going to populate it. So here we have the code that we just went over in the presentation, the sound effect that reads the asset file in initially, some accessors to set and get the looping and volume, and then the ability to play or to stop the sound. Let's use our sound effect component in the scene. To do that, we would first instantiate an Android sound pool, and then we pass the sound pool to the constructor for our sound effect, along with the name of our file. In this case, it's pop.wave. We'll get an IO exception if this file is not found or there's something wrong. And then in onHit, we just play the sound. Now, there's no reason why this needs to be a component at this point. The reason I did that is because if you wanted to do a 3D spatial sound, then you could use pretty much the same construction for a component, except that it would use the origin and the orientation of the scene the scene object, and then you could have the sound as emitting from that object. Let's add the sound effect to our application and see what happens. We can do this in onInit. The audio manager isn't found, and the sound pool isn't found. But Alt-Enter fixes that. And now what we need to do is have a declaration in there for our music or our sound. Okay, so we have to declare the audio engine and the pop sound, and we can put them up here. Remember, you need pop.wave in your assets folder in order for your application to build and run. Let's start the application. Let's look at the application on the phone now. You should be able to hear me pop the balloons as I touch the pad, and they should be different colors. If you get this result, then you have successfully added sound to your game, and let's go on and see what we can do about some scoring. We can add a scoreboard to our application using a GearVR text view scene object. This is an object that will display 2D text in the scene. It's a special subclass of GearVR view scene object. This maps an external texture onto a mesh. So the Android canvas is used to determine what's drawn into the external texture. And then that Android canvas becomes the texture on the object. So it can be any object. It doesn't have to be flat. In the case of a text view scene object, the object's flat, it's a quad, and the text is 2D text. But you can generally display the Android GUI or a web page or anything that you want in a view scene object. Here we're using text view scene object to implement a scoreboard. The scoreboard will be a blue box, and the score will be yellow text. And this will be in the scene, sort of to the upper left, and it'll follow the camera as you move. The scoreboard will always be in the same location, so you can always see what your score is. And then to put this into the scene, we would attach it under the head tracker object so that it will follow your head. Now let's add the scoreboard to our application. We won't do anything with it yet, we'll just put it in. So first, we add the code, and then we add the declaration. We're going to add the score too while we add it. So we'll put these up here, both the scoreboard and the score. We also have to add the scoreboard to the scene. Okay, and to do that, we add it under the head tracker like we did in the example. So let's go to the head tracker and add the scoreboard under it. That would be right here. Scoring is based not just on how many balloons you hit, but also on how fast the balloon is going. Reasoning is it's harder to hit the faster ones, so they should count more. And if the game's over, we won't score points. So this is the only scoring logic we need. Let's start by adding the game start and game over functions to our application, and then adding the game over flag, and that's the step one. We'll put that up here. And now we can add the scoring in the on hit. So to add the scoring in on hit, we would just take the balloon velocity and add it to the score. So let's go down here to on hit and add some scoring. And finally, we will add the timer to implement the game over, and we'll put that right after our sound. And we also need to put the timer variable in there too. And we need to put the declaration in for the timer so that it's no longer undefined. Now we're going to launch the application, and I'm going to try to score as many points as I can. You can see that the score is changing as I try to score balloons, and you can hear it popping. Now I'm not going to make you watch me play this game for an entire minute, so I'll break a little bit. I managed to score 322 points. I think that's one of my new records. Let's look at the scene graph that we created in lesson 5. So you can see that we've added the scoreboard here. It's got a mesh that's a quad, and then this text view scene object, which would be the Android canvas. I hope that you enjoyed lesson 5, and I hope you'll come back for more lessons.